There are going to be 5 steps to this problem, because there are 5 distinct phases in this process. The first step is to increase the temperature of the ice from -10 to 0 degrees, so it stays as a solid during this phase. For this step, we need to know the heat capacity of solid water or ice, and that's on one of the slides. We're going to put that number as C in this equation after we put in the mass that we're given for the ice. And my slides or the internet will tell you that it takes 2.06 joules of energy to raise 1 gram of ice by 1 degree. That's better. And the ice only increases in temperature from -10 to the melting point of water, which is 0. So we're going from -10 to 0, which is a change in temperature of 10 degrees. So the energy required for the first step of 5 is 200 times 2.06 times 10, which is 4,120. Hopefully this is joules. Can we cancel our units to get joules? Grams over grams. Degrees C over degrees C. Yes. So now we've made it to this point on our 5-step process. For the next step, we're just melting water, and we are not increasing its temperature at all. So for this process, we need to know the enthalpy of fusion of water, because the heat required to melt the ice is just the enthalpy of fusion of water times the mass that's being melted. And you can find the enthalpy of fusion on the internet or on the slides as 333 joules per gram. And we actually have here 200 grams. Grams cancel, and we get this is considerably more than the energy it took to heat the ice to 0 degrees. Try to separate these steps. So now we've made it up to here, and now we have to increase the temperature of the liquid water. I'm going to erase what I've done to tidy this up and just leave the values for joules we found for each step. That's better. For this step, we are just dealing with liquid water. So we need the specific heat capacity of liquid water, because the heat required for this step is the mass of the liquid water times the specific heat of the liquid water times the increase in temperature. Our mass is still 200 grams. We can find the specific heat of liquid water in the slides or on the internet. And the change of temperature is the final temperature 100 minus 0, or you can just think about it as the temperature change for this one step we're looking at, the step where water is a liquid the entire time. So that's 0 to 100 degrees, so a change of 100 degrees Celsius. And our units did cancel here. Grams over grams, C over C. And I'm going to clean this up again and leave just our number of joules that we found for the third step. And that brings us here to 100 degree Celsius water. What does water do at 100 degrees Celsius? It boils. So this is going to require more energy than all the other steps. Evaporating or boiling off our water liquid into water vapor. And the energy to do this is just the mass times the enthalpy of vaporization, or the enthalpy of evaporation, which is found in the slides or on the internet. We still have 200 grams of water, and that enthalpy of vaporization is I wasn't lying. Evaporating the water takes much more energy than all the other steps. So now we have vapor, we have steam, and it's at 100 degrees, we need to get it to 130 degrees, and this is our last step. We are using an equation very similar to others we have used, but this time we use the specific heat capacity of water vapor, gas phase water. The water vapor increased its temperature from 100 to 130, so there's a change of 30 degrees Celsius. So we have done the hard part, which is to find the energy required for all 5 steps of this heating process. Now we just have to add all those numbers together. And that is our final answer. I would like to point out that you can use these skills to do a wide variety of problems. For instance, if a question just asks how much energy it takes to heat liquid water from 50 degrees Celsius and then melt it all, you only have to do 2 steps of this big process. Or if a question asks how much energy does it take to evaporate iron or some other substance, you can use the same equations, but you just have to use the constants for iron or whatever substance the question is asking about.
Made with Doodlecast Pro.